We have solved example number 1 in the previous class, and also example number 2 and example number 3, if you remember. Did we solve this one? I think we did with you. So yes, today, inshallah, we will try to solve example number 4 and example number 5. Let me start with example number 5, because if we don't have time to go back to example number 5, it's okay. It is not that important. And it is clear. You can, of course, follow the steps that is illustrated for you in the slides. So let's see. I have noticed that there are many questions like this in the old exam questions. So it is a very repeated question. So here we need to find the area of the largest. So we need to maximize the area. The area of what? We need to find the area of the largest rectangle. So we have a rectangle here. We need to find the area of the rectangle. And you know, if this is the width and this is the length, the area will be L times W. Now we need to find the area of the largest rectangle that be inscribed. The word inscribed, it means inscribed in where? Inscribed in a semicircle of radius R. So we have a semicircle of radius R. Let's say, of course, you can have it this way or this way. It is a semicircle. Let's take the upper one. This means that the rectangle will not be like this or like this. No, it should be inscribed. It means the vertices of this rectangle must be on the circumference of the semicircle. It should be like this or like this, something like this. So also the other vertices should be on the diameter, like this. So what is the best case to be considered here, ya shabab? And here we need to solve it in general for any R, whatever the radius is. So the best thing to do is to draw a semicircle on the x-axis, and the vertex, the center is at the origin. Of course, this is the typical case when you have a circle centered at the origin. And of course, the equation of this circle will be this one: x squared plus y squared equals to r squared. Now, if you take any point, let's take the vertex at this point, or if you draw it this way, you can have this point, for example. Let's say any point, x and y. Now, the horizontal distance here, from here to here, let's focus on the one that we have. From here to here, what is the distance? What is the length of this part? It is x. From here to here, we have x. Why? Because this is the point. Let's say this is the semicircle. This is the point x and y. So the corresponding value here, it is x. So the distance from here to here. And the corresponding value here, it is y. So the distance from here to here, also the length of this side is y. So here we have x, here we have y. Now, this is the rectangle. What will be the width? The width of the rectangle, or the height, will be y. And what will be the length or the base of this rectangle? It will be x, and also here we will have the same length. It will be 2x. So here the area will be y times 2x. 2x. So we will have it like 2xy. Okay. Now we want to maximize this. We need to find the maximum of this function, the area. The problem here that we have it with two variables. I should have only one variable. So I need to find the relationship between x and y. And here it is. I can find it from the circle. So now eliminate here, solve this one for y or for x. Let's solve it for y. So here we are. This is a equals to 2xy. Solve this equation for y. What you will have? And you are supposed to have positive or negative. R squared minus x squared. But you know here, ya shabab, y is representing a length. Also, it is in the first quadrant. But not only that, it represents a length of a side of a rectangle. So it must be positive. We will not consider the negative case. So this is y. Now, both y here, you will have a function 2x times r squared. R is a constant. It is not a variable. It could be 5, 25, whatever. So here we have a function now. This is a function of x, a function of one variable. Now we need to ask ourselves, what are the possible values of r? R here, x, because we need to find the domain of this function. So x is what? X is, what is the largest value for x and what is the smallest value for x, ya shabab? If you look at here. X, of course, the maximum number that can it has it R. So the maximum value for X, this X, it could be here, or if it is here, you have R. Now, if it is here, you will have 0. طبعا it could be here. If X can be from negative R to R, we can write this. But here, يا شباب, X is what? X is a length. X is the length. It is the half of the side of the rectangle. So we cannot have it negative. We should have it positive, because it is a length. We having a particular problem, practical problem. If it is negative, for example, if X is negative, this will be negative. The area cannot be negative. So we must have it positive. So this will give me the domain now. My X is between 0 and R. Is that clear? So you should know what are the conditions on your variable. Now, خلاص, if you have this, يا شباب, it is so easy. Just now find the derivative. Find the derivative by using the product rule. If you use the product rule, you will find the derivative. And you need to simplify طبعا to make it over a single fraction. Multiply this by this, simplify, and you will have this at the end. What you will do next, you will put it equal to 0 to find the critical numbers. If you put this equals to 0, what you will have? You will have R squared minus 2x squared equals to 0, which means that 2x squared equals to R squared, x squared equals to R squared over 2. Now, x will be positive or negative, the square root of R squared over 2. But we will not consider the negative because x is positive. So we will take only positive case. So x will be, also R is positive, so it will be R over square root of 2. Which you can write, of course, as 2 R square root of 2 over 2. Now, this is the critical number. Of course, you need to make sure that it is between, X is between R and 0. So this number is between R and 0. Now, if you remember, our X now is in a closed interval. So we need to find the absolute what, ya shabab? The absolute maximum or minimum? The absolute maximum. The absolute maximum now, to find the absolute maximum, you need to consider the value of the function at 0, the value of the function at R over 2, and the value of the function at R. For the value of the function at 0, it is clearly when X is 0, this will be 0 because of this. And also when it is R, if X equals to R, this will be 0. And we have it 0 in that case. So for sure, ya shabab, for sure, this is a maximum. And you can, of course, check this. This is a maximum because here we have 0, 0. The area cannot be smaller than 0, of course, but it could be bigger. Now, what you will do, you will find the value of the function at R over 2. And here we are, both here, X equals to R over square root of 2. You have 2 times this, and you have at the end R squared. So what does that mean, Shabab? The area of the largest rectangle that can be, if you have a semicircle with radius R, the largest area for the largest rectangle that can be inscribed inside this semicircle must have an area equals to what? The square of R. So the area here should be R squared. And of course, you can find this is X. X is R square root of 2. You can solve it, of course, to find what is Y. And of course, Y will be square root of 2 times, in that case, R, what will be R? Y. Here is Y. Just put X equals to here. And you know that it is 2XY. Now you have 2XY equals to R squared. And 2R over square root of 2Y equals to R squared. Now this means that you have here square root of 2 equals to R. So in that case, also Y is square root of 2. So it should be, of course, in this case, it should be R square root of 2, and this should be square root of 2R. These are the dimensions of this rectangle, and this is the area of this rectangle. And there is another way. I don't want to focus on it. There is another way. I just mention it here for you, for those who are interested in. You can solve this one, by the way, Shabab, without calculus, just by using the trigonometry. Now draw a line from here to the middle. Let's consider this the center. This is the center of the semicircle. Draw a line like here. This will be the radius. This will be theta. Also, this will be theta. And this will be R. Now, if you look at theta, this will be R sine theta. This will be R cosine theta. Simply, what will be the area, Shabab? It will be r sine theta, the width or the height, times the base, times 2r. So you will have the area to be a function of theta. It depends on theta. It will be r sine theta times 2r cosine theta. Multiply, it will be 2r squared. Cosine theta times sine theta times 2, it is sine 2 theta. Now this is the area. What is the largest value that you can have here, Shabab? What is the largest value for sine 2 theta?
45
You know that
pi over
sine
4.
theta is less than 1, greater than or equal to negative 1. So the largest one here, it is 1. So put it 1. You will have a at theta equals to r squared, which is the area that we have. Simple like that. And if you need to know what is theta that you need. Theta will be pi over 2, theta pi over 4 will be. Very easy question if you want, but it cannot be, you cannot use it, of course, with all the problems, but it is an interesting way if you have an idea about it. In 3 minutes, we need to think together, Shabab, how to solve this all the exam question. Also, I want you to have an idea about the numerical problems like this. Find a positive number. So we will call it x, ya Shabab. Find a positive number for which the sum of its reciprocal, what is its reciprocal? 1 over x. This is the meaning of the reciprocal. And 4 times its square. Its square is x squared. So here we have 4x squared. Is the smallest, so we need to minimize here. We need to find the minimum of which function. What is the function that we want to minimize, ya Shabab? The sum of what? Its reciprocal.
X plus 1 over.
And this is the function that we want to minimize. Halas, so easy, ya Shabab. طبعا here what we have, what we know about x. X is greater than 0. It is positive number. So with the domain is from 0 to infinity. What we will do, we will just find the first derivative, which will be negative 1 over x squared plus 8x. Now we will both just simplify it. It will be negative 1 plus 8x cubed over x squared. Now both it equals to 0. What you will have? You will have negative 1 plus 8x cubed equals to 0, which means that 8 cubed equals to 1, which means that x equals to 1 over 2. Am I right? So x is what? X is a half. So this is the number that we are looking for, and the answer is E. So where is the main step, Shabab, is this. If you have the function that you will minimize or maximize, you are done. And consider also the domain of your function. And you have also many questions, ya Shabab, that they are here included in this section. I have put here a lot of problems because I want you to practice, and most of them are solved. Okay, now let's go, ya Shabab, to the. Do we have time? In 1 minute, let me show you the idea of this problem. Do we have time for that? I may delay this to another time, no problem, to have time for that. Now, please, ya Shabab, read this problem. It is clear and readable, and you can understand it very easy. If we have time, we will do it next class, inshallah, or I will leave it for you. Now, let me stop recording, and we need to get ready, ya Shabab, to go to the Microsoft Teams. But wait a minute.